Hey, it's you again. Well, since you're here, let's talk about inequalities for just 1 second. So, away we go. Don't forget inequalities. We have linear lines that look like this. I'm trying to. Can you see it right here? You can't see a thing. If I cover it. All right, we'll just. Bye. So we have y equals mx plus b, which makes a line. I think I can add something here. I want to add. Here we go. Man, that is a bright graph. Okay, so that's mx plus b, and it makes a straight line that kind of looks like that as it goes through all this. I can do a little better than that. So where m is the slope, b is the y-intercept, but today what we're going to be talking about is if we get rid of the equal sign, and instead we're going to write one of these. So the first thing, don't forget your more ink and less ink rules. They are in full effect here. So for the more ink rule, if there is more ink in your inequality, then the line needs to have more ink. And if there is less ink in the inequality, so one of these, there should be less ink in the line, like that. And that also works really well with the open and closed circle. We're doing domain and range. If it's a closed circle, then it has more ink, so we're going to use one of these. And if it's an open circle, it has less ink, so we're going to use one of these. So in this case right here, y is bigger than or equal, so we, in this case, would shade above. Yeah, you can see that. Awesome. I kind of wish you guys could see what I see because it's so bright and vibrant. You can't see it. So in this case, we would shade above like that. And I'm ruining my marker over here by covering it in pink. Okay, so let's talk about some problems. So don't forget that if it's this way, it says y is bigger than the equation. So we would shade above. If it's the other way around, this would say y, the output, the graph, is less than the line, so we would shade below the line. So that is just a quick and easy reintroduction into inequalities. Let's start with some pretty simple word problemos. That's problems. For those of you who don't speak Spanish, that's how you say problems. Problemo. I know it's problemos. Please don't email me. Here we go. Get this out of the way for now. Here we go. Sarah is selling bracelets and earrings to make money for summer vacation. Bracelets cost $2. Earrings cost $3. She needs to make at least $500. I didn't say why she needs to make $500, but we'll just assume that if she doesn't make $500, she's going to have a bad summer, and she wants to have a good summer vacation. You can't have a good summer vacation without $500, apparently. So here we go. I'm going to label, you can use X and Y. Let's just use B and E to make it easy. Breakfast and eggs. Bacon and eggs, that's B and E. We'll do bracelets and earrings. So for money-wise, 2 times all the bracelets. B is going to be the number of bracelets sold, and E is going to be the number of earrings sold. So that number of. So 2 times the number of bracelets sold. That'd be all the money she made selling bracelets. She sold 10 bracelets, she made $20. 2 times 10. And 3 times E, and I'm going to use a capital E here, that would be how much she made selling all of her earrings. And if I add that, that is how much money she made all summer long. Now, we do have this word here, at least 500. So we have some options. I could have one of these, one of these, one of these, or one of these. I don't know which one goes there. I'm going to give you a minute. Pause it, think about it. Have one of these in your brain, which one you think it should be, and I'll explain which it will be and why. Okay, you paused it, you have unpaused it. Welcome back. I hope you have an idea. Let's talk about, first of all, should it have the equal sign or not? Use those words at least. Use it in a sentence. If I say you have to have at least an 80 to go on the field trip, and you have an 80, can you go? Yes. Yeah, you have at least an 80. You got the 80, so we do know it's going to be one of these. It does have the equal sign. At least $500. So she can make $500, but now the next question is, which one of these should we use? So this is how much money she'll make. If she wants to make at least $500, she wants to make more than $501 will be fine. $510 will be fine. She can make $600, and that will be at least $500. So I want this side of the equation. This is how much she makes. I want that to be bigger or equal to 500. Because then this is how much she makes. That is at least 500, but it could be more. It could be a lot more. It could be $500 exactly. It could be $500 and 1 penny, which wouldn't make any sense because there's no pennies going on here. Let's look at the next one. Why did I say that? Why did I have to say something about a penny? All right, here we go. Let's do the next one. It's out of here. Here we go. It wasn't supposed to look like this. All right, if it was originally supposed to look like that. See, normal pizzas and normal cookies, but it makes it kind of hard to read. So we're going space cookies and space pizza. Pillar is buying pizzas and cookies for a party. Is that supposed to be? Pizzas cost $9 each. Cookies cost $5 per pound. That makes sense. Pillar wants to spend no more than $50, but she needs at least 3 pizzas and at least 2 pounds of cookies. So let's start with the money. Well, let's start by labeling some of these things. We'll say we'll use C and P. C for pounds of cookies and P for number of pizzas. Okay. We know their cost. We know their cost. Their cost is 9. I'm right on top of the problem. Right now. The cost is going to be 9 per pizza and 5 per pound of cookie. And we want to make sure that is no more than 50. So this is how much we spend. I want this to be less than 50. Could it be equal, though? Could I add that little line right there? Do you have an idea? The answer is yes. Yes, I could. No more than 50. It could be 50, just no more than. No more than 50. Now, she needs at least 3 pizzas and at least 2 pounds of cookies. I'm not sure what to do with that second part because it doesn't say to keep it less than something. I would just say, I could say now that the number of pizzas, write this a little bit somewhere else. We got a couple more little inequalities here. That the number of pizzas she buys, is it still underneath that? Oh my goodness. The number of pizzas she buys, she needs at least 3. So the number of pizzas needs to be bigger or equal to 3. And the number of cookies needs to be bigger or equal to 2. So those will be our 3 inequalities there. One for these 2 for how many of each. This one for pricing. Now, let's talk about the whole reason you came here today, and that is to talk about these points. I know you watch this video and you're going, man, I knew all of this. I need you to tell me about those random questions you have. So what is in the solution? Oh, you can't. Oh, I can't. It's not transparent. I thought it'd be transparent. Let's see if we can't fix that real quick. On the fly here. Well, that works for the bottom. Didn't work for the top. Hugh. He's no guy named. Hey, there it is. I figured it. I fixed it, everybody. You're welcome. Okay, so what points are in the solution? That would be a point that is in this shaded line right here. If it's underneath the shaded line, it is in the solution. So points that would be in the solution, I can't really show you, boss, from over here. So in the solution would be points like the y-intercept, or not the y-intercept, 0 and -2. That is in the solution. It's right here in the solution. Anything in this solid shaded region is going to be in the solution. So we can name some more like 0 and -4. That's in the solution. We can even do 4 and 0. That's in the solution. We could say 3 and -3. That's in the solution. Let's talk about what's not in the solution. What's not in the solution? The origin right here, 0, 0. That's not in the solution. Another one would be 2 and 1, 2 over 1 up. That's not in the solution. That's going to be right here, 2 and 1. That is not in the solution. Let's name 2 more. How about -1 and 1? -1 and 1. That's not in the solution. And finally, 1 and 1. +1, +1. 1 over 1 up is also not in the solution. None of these are in the dashed or in these shaded regions. So here's my question for you. What about this point? I'm gonna change colors so you know I'm talking about something a little bit different here. What about this point? 0 and -1. It is the y-intercept, and it's on the dashed line. Is it in the solution or not? I bet you're asking yourself, where does it go? The answer is it is Not in the solution because this solution is a dashed line, where the dashed line means not equal to. Not equal to. So if a point is on the dashed line, that would not be a part of the solution. Another example here would be 3 and 1. 3 over 1 up. That's a pretty point that is on the line. And what is on a dashed line is not in the solution. Let's do one more. Erase all this. And we'll do our last problem, and then I can post all this. How about these two right here? I probably should start with this one. Can I see behind this one? Not really. Let's see if I can't fix that. That did not help. That did not help. That did not help. All right, nope. Okay, well, we're going to, it is what it is. Let's go ahead and just jump right in. So I'm gonna name some points, and we're gonna find out if they're on which graph. So we have the green graph over here. We have the yellow graph over here. They're going to head-to-head competition to see which graph is a graph. I don't know. So this one I can definitely see. This would be y is greater than some equation. This one would be y is less than or equal. Notice here, shade above, dashed line, shade below, solid line. So the first point I want to do is 0, 0. And I'm putting right here, 0 and 0. Is this in the solution for both? So 0, 0 is in the solution here, and you can't really see it. But yeah, it is in the shaded region for both of them. Pretty good there. Let's talk about 2 and 4. We'll say 2 over and 4 up. Here, 2 and 4 is 2 over and then 4 up. Definitely in the shaded region. And here on this side, 2 over 4 up. I can see that point. Yeah, also in the shaded region. It's a solution for both. Let's talk about a couple more points here. How about 0 and 6? 0 over 6 up. On this graph, it is here. Not in the shaded region. This is not a part of the solution to this graph. But 0 and 6, that's way over here. That is a part of the solution on this graph because it is in the shaded region. Let's do a couple more here. How about 2 and 0? Give you a second there. 2 and 0. On this side, yeah, 2 and 0, clear, 2 over 0, definitely in the shaded region. But over here, 2 and 0 is the x-intercept. It's where it crosses the x-axis. And that is a dashed line. This is not a part of the solution. Some more to do here, and then I'll be done with it with this lesson video. Let's do -1 and 0. -1 and 0. 1 back, 0 up. On this one, yeah, it's somewhere in this area over here, so definitely a part of the solution. This one, -1 and 0, that's right here. It's on the solid line. It's on the solid line, and we know that the solid line is equal to. So yes, it is a part of the solution for both. If the point is on a dashed line, not a part of the solution. If the point is on the solid line, is a part of the solution. Let's do some more. Let's do 2 more, and we'll call it a day. How about a -6, -8? It's gonna take you a second to find it. Here, -6, -8 on a dashed line. On a dashed line, not a part of the solution. -6, -8, -6 here, 8 down. Looks like it's going to land right here. Neither one. It's right there, not here. It is clearly outside of the shaded region. This is not a solution for either equation. And I think that is, we're going to do one more here. Let's do -5 and -8. One more here. -5, -8. We're just plotting these points, and we're just going to see if they're in the shaded region. You could have also done this with the graph. Or with the equation, you just plug these numbers in and see if you get a true statement back, if it is a bigger number bigger or less than. So here we go. -5 and -8. -5 and -8 is going to be here, not in the shaded region. -5, -8 here, 5 back, 8 down. Boom. On a solid line is a part of the solution. So there you go. Mark all that, apply. Reach out to me if you have any questions. I think that's it. Have a wonderful break. Bye.